Going on, guys, let's do this problem right here. So it's asking to integrate this one using U-Substitution. So first of all, we have this one right here. So we have to, whenever we have something like that, we pick up a u that is gives the derivative. Like for example, if it's x, if we find the derivative of this one, we have to get x. So but this one we can get this, but since we have two, we can't do anything really. But we can randomly become something like, let's u is equal to 1 minus x square and see what happens. So we have u is equal to 1 minus x square, and if I take derivative of this one, this is going to be equal to minus 2x dx. And then so we have to create a relation like this, x dx. If I find something like this, I can substitute in the next one. So if to make this one, I can bring this minus 2 to the other side, so it's going to be du over 2 minus du over 2, and that's going to be equal to x dx. Now we can substitute this one into the next equation. So we have the new equation right here, that is minus half. So I am bringing this minus 1 over 2 to the front, and then we have 1 over, this is 1 minus x square is going to be u, and square root of 1 minus x square is going to be square root of u. And instead of x dx, we plug half du. So we have plugged half already, so we have to plug du now. So this is going to be du. Now we have another integral. Now we can use a substitution method again. So let's pick up root u for the, let's say v. So if v is equal to root u, then if I take the derivative of this one, this is going to be so I can eliminate this u by squaring. Okay, so let's square this one. So v square is equal to u. So if I find the derivative, this is going to be 2 2v dv is equal to du. Now we have to bring in everything in terms of v. So we have this one, we have created relations for du, and now we can simply substitute in the next equation. So I bring this one right here, and that's the next equation is going to be minus half remains the same. Then we have, instead of du, we plug 2v dv. So 2v dv instead of du. So this is going to be 2v and dv right here. And in the bottom we have u. So instead of u, we can put v square plus, instead of root u, it's going to be v. So this is the new equation that we have. And then what we can do, so let's see. So if I take the v common, I can cancel. Okay, so if I take, this is minus half, and we have integral. If I we have 2v in the top, if I take v common, this is going to be v plus 1. We can cancel this 2v, and we also can cancel this 2, and we have left with minus integral of 1 over v plus 1, and also we have a dv right here. So 1 over v plus 1 dv. So if I take the antiderivative, so I have to take the antiderivative of this one. So whenever we have something like 1 over something, we know that is ln, because we know that derivative of ln is 1 over x. So it's same type pattern right here. So if I see something like this, that's going to be ln. So in this case, this is going to be minus. If I take the antiderivative, this is going to be minus ln, and this is going to be v plus 1 plus constant. So that's going to be the antiderivative. And then so our main thing is we have to bring this into the original format, like right here, that's in the x pattern. So this pattern, that's the purpose. But first we have, this is in v, so I have to convert this one into u. So we know that v is equal to root u, so I can plug this one instead of v. So this is going to be minus ln root u plus 1 plus c. Now our main thing is this one 1 minus x square, so we can plug that one right now. So this is going to be minus ln square root of 1 minus x square plus 1 plus constant, and that's the final answer. I hope you guys like this video. See you next time.